On to Chapter 8, Section 1, Quadratic Equations. The principle of square roots, completing the square, a very important topic, and some problem solving. Now, we'll look at first the principle of square roots. And we're dealing with quadratic equations, that is, our degree is to the second power. So let's consider x squared equals 25. We know that the number 25 has two real number squares, square roots, a 5 and a negative 5. That is, if you square 5, you get 25. And if you square a negative 5, you get 25. The solution of the equation. Thus, we see that the square root can provide quick solutions for the equations of the type x squared equals k, where if k is a perfect square, it's going to be the plus and minus of the square root of that. And that's what they're illustrating here. For any real number k, and if it's a perfect square, then it comes out of the radical sign. If it's not, then it stays under the radical sign. But you do get two values. You get a positive value and you get a negative value. That's key. So let's solve this one. And they're asking us to find an approximation to 3 decimal places. Well, what are they doing here? And I'm going to use some of this. We want to isolate the x squared. So we're going to divide both sides by 5. And that's where we get x squared equals 3. Now, what do? Well, we take the square root of the left, which will be x, and then the square root of the right, which, remember, there's going to be a positive and a negative, using the principle of square root. And if we put that in our calculator, it rounds off to this, to 3 places, and a negative this, to 3 places. Now let's do this one. And I'll do one too. So what do we do first? Well, it's going to be 16x squared. We're going to bring this now to the other side as a negative 9. Now we're going to isolate the x squared by dividing both sides by 16. Then we get x squared equals, let's make a nice equal sign there, a negative 9/16. Now what do? Well, we take the square root of this side. That's going to give us an x. And then the way I do it is we get then plus or minus the square root of a negative 9/16. And you might say, well, wait a minute. You can't have a negative under a radical sign where the index number is 2. Well, in our previous lesson, we said we could take out the square root of 1 here, and that would be plus or minus I then, the square root of 9/16, and we know then that both of these are perfect squares, and we usually write it as plus or minus 3/4 I. So there's the sequence of this, and they'll show it to us as well. So we transpose, and they're already isolating it. And again, I don't like the way they're writing this. And they're taking the square root of both sides. This one's positive, this one's negative, and they're getting our answers. Keeping in mind that I is the square root of -1. Often a way to write it as is the way we showed. Plus or minus 3/4 I. I like this, the way they're showing that. So for any real number, they're repeating that rule. This is the principle of square roots. But again, you always have to ensure you get a positive and a negative value. Now, we're moving into something a little different, where instead of this just being x squared equals 7, it's this binomial squared equals 7. But the same rule applies. So let's write it out. X plus 3, the quantity squared, equals 7. So what do? Well, we take the square root of this side. Remember, this index number is now 2, and that's 2. So this just becomes the radicand. And we do the plus or minus square root of the other side there. And now what is x? Well, x by itself, we have to transpose the positive 3 to the other side as a -3 plus or minus the square root of 7. So we are introducing now a technique that will take a trinomial, that's a perfect square trinomial on this side, that we can factor into a binomial squared equaling something, then take the square root of this using the principle of the square root and solve for the letter x. So they're taking the square root of this side, getting this, and then the square root of the 7 using both the plus and the minus, and then finally transposing the positive 3 to the other side. So I think my way may be a little bit more useful for you, and the answer is there. Now, it says not all quadratic equations can be solved as is shown in the previous examples. By using a method called completing the square, though, we can use the principle of square roots to solve any quadratic equation. And that's where we're going. So this term of completing the square, you don't perhaps know what it refers to yet, but I will illustrate it. Okay, let's take a look at this one here. Can you all see this is a quadratic equation in standard form? Now, up to now, we've been factoring these, but this doesn't factor. But there is a method that's called completing the square, in which we look at our A term, which is a 1, our B term, which is a 10, and our C term, which is a 4, and we follow this procedure. They'll give you a summary here shortly. So let's write this out. X squared plus 10x. Now what I'm going to do is take this positive 4 to the other side over here. And on the other side it becomes a negative 4. So it's not in standard form anymore, but we're using the principle called completing the square. We want to make this into a perfect square trinomial that will factor into a binomial square. And again, we have an equation, so whatever we do to this side, we must do to that side. So, if you recall that in a perfect square trinomial, I'll do it that way, which became a squared, we multiplied these and doubled it, we got 2ab, and then we squared this term, and we got b squared. Okay? We squared our b. Now, we know that this is going to be x because a or x squared is this. Now, what did we do to these two terms here? And we know the middle sign is going to be plus to figure out what is my b term. Well, in this case it was half because we multiplied it by 2. So the rule we're going to use is what is half of 10? Half of 10 is 5. And I'm going to change colors here. Now, how did we get our c term if we had this? Well, we squared the b in this case. So we're going to square 5 and get 25. Okay, so we've put a new value here. To keep this an equation, we must put the 25 on this side as well. So we now have a perfect square trinomial that factors into this. And this now is going to equal 21. And how did we do this? Well, we took the c term over to this side, and this is ax squared plus bx plus c. This is the c term here to the other side. Then we took half of b, and we got 5. And then we squared 5 and got 25. This process of squaring 5 after we took half of it, this is called completing the square. What's it called? Completing the square. And this was the process. Now once we square it, we then factored it, but we already have it factored in a sense, into a binomial that's factored. Now what do we do? Well, we're going to take the square root of that side, which just gives you the radicand, and I got to write that correctly here. Use the right letter. X plus 5 equals, now we took the plus or minus the square root of that, and now we're going to transpose the 5 as a negative 5, and that is the solution of this quadratic equation that we solved through the process of completing the square. It's in standard form. We take the c term, bring it over to the other side. I put my little parentheses because I want to make this a perfect square trinomial that will factor into a binomial square. Took x goes there, the plus goes there, half of this is 5, and there I have it factored. But then to make the perfect square trinomial, I had to square the 5, 25. Put it on both sides, so it's still a balanced equation. Do my subtraction, take the square root of both sides, transpose the positive 5, and there we have our solution. Wow. And that's what they'll show us here now. So this is a perfect square trinomial. Now what technique did I show you? Well, I put the parentheses down there with the squared. This. Okay? They're doing it afterwards. I like to do it ahead of time because it leads to this. And there's your answers. So, here are the steps. If you want to write any of this down, you can. Pause the tape. And now we're doing another one. And by the way, on the additional exercises, I work a lot of these out for you. So here's a word problem. After 1 year, the amount of money P, that's the principal, invested at 4% per year is worth 104% of P, the principal. If that amount continues to earn 4% interest per year after the second year, the investment will be worth 104% of your original 104%. And this is called compounding interest. Since after the first period, interest is earned on both the initial investment, your original principal, and the interest you earned on that. And generalizing this, working it into a formula, you end up with this formula right here. And keeping in mind the rate is written in decimal notation. And A is the amount that that principal grows through T number of years. All right, there's a nice formula. So it says Jackson invested this much, that was his principal, at an interest rate of R. We don't know what that was to be compounded annually. In 2 years, this principal grew to this amount. What is the interest rate? So we've read the problem. There's our formula. So what we're going to do is substitution. There's our initial principal. There's the amount to which it's grown. And the time is 2 years. We want to solve for this R. And let's take a look. Now again, what they're showing is they're dividing both sides of the equation by this. I don't like the way they show it. And then we have to take the square root of this side. That gives us, since we have a 2 here, the square root of this side, and plus or minus the square root of the other side. It takes away the exponent now, and we get that. Now we're going to subtract 1 from both sides, and we get R equals this. Now, since we have made money, we reject the negative of this radical, and we get then that R is approximately 8%. and we reject this one. This is the negative. We're rejecting that. Since the interest rate cannot be negative, we only use the 8%. And it checks. Now, I'm going to go back a little bit because this is almost the end here. I'm going to go back to this state here. Well, in fact, I'm going to go back to this one. Oh, I don't have any room there. So I'll use this one. Okay. So this was the original. We just substituted the principal and the amount into that original formula, where this was our P and this was our A. Now the first step we do is to isolate our exponent here, sort of, by dividing both sides by this. And this is what they're showing you actually in this slide here. So these cancel out, and we now get this. So now we have this binomial raised to the second power. Well, how do we want to solve for r eventually. So here, we're going to take the square root of that and plus or minus the square root of that side. And you can put that in your calculator. And this will then become 1 plus r. Now we're going to transpose that r. That becomes a negative 1 plus or minus the square root of this. Now, this 1 is gone because it's for the other side. Now, since we can't use negative, this negative is there for sure, but this negative value of this we can't use. So we can kind of cross that one out too. So what we do is we're going to get a value here, and it comes out to be, once we subtract it, it's like a negative 1 plus this is approximately 1.08. When we find the square root of that, it's approximate that. So we get r equals 0.08. And that is our rate. Okay? And this is approximate. We reject it because the other one would have been a negative that. We reject that because there's no interest that's ever like that. Okay. Now I'm going to give you one more example of completing the square. And in blue was my original equation in standard form. And to complete the square, we want to have our A term here as a 1. So what I will do is divide every term by 2, which is what I've done. And now my A term is 1. And I said, what's the first thing you do? Well, you transpose your C term to the other side. Then I said, put parentheses, like so. The X goes right here. The plus goes right there. And now, remember, this is gone, so I'm going to just erase it. And what we have to do is complete the square. Now, what do we add here to make our C term? Well, we have to take half of our B term. And what is half of 2? A 1. Okay. Actually, I picked an easy one here. If we square 1, we get 1. So we have to add that 1 to both sides of the equation, by the way. We transpose that. So we now have x plus 1, the quantity squared, equals a negative 4. And what do we do now? Well, we've completed the square. We have a binomial squared. We take the square root of both sides. And this just becomes the radicand. This is like a really cool process here. And this is going to become plus or minus. Now notice this is a negative 4. So how about 2i? And we just now transpose our positive 1 to the other side as a negative 1, plus or minus 2i. Wow. And there's just another example. Again, in additional exercises, I work out a lot of completing the square, and it's under topic 8.1. So that will wind us up.